This is FRQ 2008, number 4. This is now the non-calculator portion. All right, so we're going to have to use our brains a little bit more for my calculator. Wait. Particle moves along x-axis, so the velocity at the time. All right, so this is velocity. This is the one where we talk about that. This is the first derivative already. If we're looking at the original function, you have to look at the area under the curve. If we're looking at the acceleration, which is the derivative of this function, you have to look at the slope at the point that they're looking for. Okay, so again, give yourself a little note here. This is already the velocity. So if we want the original function, if we want s of t, we're looking at the area. If we're looking at acceleration, a of t, we're looking at the slope. All right, so remind yourself, all right? Okay, so the velocity is 0 at t equals 0, at t equals 3, so right here, and at t equals 5. So velocity is 0 at those points. And the graph has a horizontal tangent at t equals 1 and t equals 4. So those are our maximum points, all right? The areas of the region bounded by the t-axis, and the graph of v on the intervals between 0 to 3, 3 to 5, and 5 to 6, so draw that down, are 8, 3, and 2, respectively. Now be careful. They say it's 8, but it's really negative 8 because it's below the x-axis, and this is really negative 2 because it's below the x-axis. At t equals 0, the particle is at x equals 2. So this is what we started with, all right? So between 0 to 6, what is seconds? Nope. Anyway, between 0 to 6, find both the time and the position of the particle when the particle is farthest to the left. Justify your answer. Well, negative area means that it's moving to the left. Positive area means it's moving to the right. So when is it farthest to the left? Well, you're looking for the fact that it started at negative 2 and went farther, negative 8. Right? So you want to check both the negative areas, right? So we check the fact that for part A, let me see if you can see this. I'm going to scoot this up then. All right, so for part A, we're looking at x of 3, right? What happens when I am at t equals 3? Well, I have negative 2, right, plus the area, so plus the area between 0 to 3. So plus the area, which is now really the integral between 0 to 3 of v of t, right? So that's negative 2 plus negative 8. That gives me negative 10. Okay, the other one I need to check is the more addition of negative area, right? So what about x of 6? Well, I start with negative 2, and I need to find the area from 0 all the way to 6, v of t. That's the distance traveled in that time. So I have negative 2 plus this negative area, so negative 8, plus a 3 up here, and minus 2. So that would give me negative 4, negative 12, plus 3, that's negative 9. So who is more negative? Right here. So the furthest left, so you are farthest left at t equals 3, and x of 3 equals negative 10. Your position is negative 10. So that's what the question was asking. It's asking the time and the position. So time and the position. Okay? All right. Part B, for how many values of t between 0 to 6 is a particle at x equals negative 8? Explain your reasoning. Well, I know these 3 pieces of area. That's all I know. So let's see. The particle starts at negative 2, right? And at the end of 3, t equals 3, at t equals 3, it's now at negative 10, right? Because negative 2 plus negative 8 gives me negative 10. Okay. Now, at t equals 5, so negative 10 plus 3, it is now at negative 7, right? And then, again, in one more second or one more time unit, at t equals 6, we're going to subtract 2, now at negative 9. So it went from negative 10 to negative 7. That must pass through negative 8, right? And then it went from negative 7 to negative 9. It must pass through negative 8 again. Negative 2, negative 10. Did I pass enough times? Oh, sorry, let me back that up. So from here, I started at -2, I went to -10. That went through -8 once. Now it went down to -7, went past through -8 again. Now it came back up to -9, passed through -8 one more time. So 1, 2, 3. So by intermediate value theorem, because the number exists between two y values, right? The y value you want, which is -8, it is between the two y values that you see here. So by IVT, it must pass through -8 at least 3 times. We don't know. It may pass more, but that's all I know based on the picture here. So we know at least 3 times. There could be more. Okay? All right. Next, in the interval between 2 to 3, so 2 to 3 here, 2 to 3 here, is the speed of the particle increasing or decreasing? Give a reason for your answer. So this is something we haven't really discussed, but when they ask you for speed, you want to look at 2 things. You want to compare the velocity and the acceleration. So the way I'm thinking is that if the acceleration is helping along the velocity, it will help the speed go faster. So when velocity is positive and acceleration is positive, acceleration is helping it. So of course, then they're both heading in the same direction. Your speed will be positive. Speed will be increasing. Same thing. If your velocity is negative, negative only means direction, right? And acceleration is also negative. They're both heading in the same direction. Then your speed is also increasing. So in other words, if your velocity and acceleration have the same sign, they're both positive or both negative, your speed is going to increase. If your velocity and acceleration, one is positive, one is negative, they're working against each other, then it makes sense that your speed is going to slow down. So if one's positive, one's negative, they have different signs, then your speed is going to be decreasing. All right, so that means we gotta look at 2 things. We'll look at the velocity and we'll look at the acceleration. So between 2 to 3, what is happening? Well, between 2 to 3, my velocity is negative, right? V of t, my value is negative. Sorry, let's move this up here. Between 2 to 3, my value is below the x-axis. So V of t is negative in 2 to 3, right? Oops, this is very hard. Let me try to move it up again. All right, so let's try this again. Between 2 to 3, the velocity is negative because it is below the x-axis, all right? But acceleration is what? Well, acceleration, I said acceleration, look at the slope. The slope in this case right here between 2 to 3 is actually positive. So it's positive between 2 to 3. So velocity is negative, acceleration is positive. They are working against each other. So now your speed will decrease because they're working against each other. Okay, and that's it for part C. All right, during what time interval is the acceleration of the particle negative? Justify your answer. Okay, so remember we're looking at acceleration being negative. So when is the slope negative? Well, slope is negative in this picture right here and right here. So I will say part D, acceleration. I really can't fit both of these, but okay. Acceleration is negative in the interval of 0 to 1, because remember in the beginning it told us that it reaches 0 right here at 1, right? And in the interval between 4 to 6. Why? Because the slope is negative. And that's it. That's it for number 4.